My name's Whitcroft. I'm here with one of my various hats on today as part of the WikiHouse Foundation, which is a non-profit, and we are, to segue wonderfully from that last question, we are an open source hardware project developing solutions and technology, both hardware and the IT infrastructure, to help self-build and custom build to scale, particularly in the UK, but globally as well. I don't think we've ever had, giving talks on WikiHouse, two quite as perfectly complementary talks before us. So I may skip through a few slides that have already been covered by someone else's amazing talk. So we take a slightly different approach, but again, doing exactly what Craig was talking about. How do we solve this problem that it's complicated and long-winded to build and it's difficult to scale in the UK? And our solution, our sort of focus is around digital fabrication and leveraging new technologies and new ways of approaching and procuring buildings, for sort of starting from the ground up. So a little bit of context. Since early 1970s, house prices in the UK have gone up by about 5,000%. In the same period, our wages have only gone up by that amount. So this obviously means that this is, well, buggered the housing market, basically. This is, as Craig said, a diagram showing the state phasing itself out of producing housing. And the non-profit and also the private sector just hasn't increased. It's not because they're evil or bad people, it's just because they're not designed as companies, as organizations, to do what we're asking them to do, which is produce hundreds upon hundreds of thousands of houses a year. So that's what's happened to prices over the same period, understandably. And there's also some other weird things about how our housing market works. This is actually Birmingham city centre. What you're looking at is council-owned land, which is considered marginal unviable site that they could build on. It's available, hasn't got buildings on already, and that's enough land for nearly 5,000 homes. But in our current procurement models, they're considered financially unviable. But with self-build and custom build and things we've been talking about today, they are viable, the sites. It doesn't seem like very much, but if we say we're building 130,000, 120, 130,000 houses a year in the UK, and that is what we're building, year on, year out, that's actually quite a substantial portion of that market, just in one city, just council-owned land. So this isn't quite what our cities look like anymore, but this is actually what we're doing still, top-down development. And this is a lovely quote I try and show every time I give a presentation, which is from Jane Jacobson. The cities have the capacity to provide something for everybody only because and only when they are actually created by everyone. I think it's a really, really poignant quote. So how can we go from this, which is not working, it is broken, top down, one person with a lot of money, building cookie-cutter housing, because that's the only way they can do it, to this, sustainable, community-led, customized. How can we create this? A new sector, a citizen sector. At WikiHouse, we don't actually quite agree with the government's current terminology on custom build. We think it's actually just too vague and undefined. And we think it'll evolve. It's only a sort of emerging into the mainstream usage relatively recently. But we like this idea of the citizen sector. Actually, it's not just something wacky and unusual. It is a viable sector in its own right. And so where WikiHouse emerges out of this is this idea of the third industrial revolution, which is a coming together of the kind of technologies and influences that have affected the web over the last 10 years or so, and how that's going to bleed over and change how we make physical things, whether that's our houses, our products, furniture, etc. So, open source, Creative Commons licenses, this is the idea of the open web. We don't have to solve problems twice, we can just solve them once and share that content. And it can be licenses that protect that intellectual property, so someone can't just say, right, I'm just going to take that, I'm going to black box it, I'm going to make lots of money out of it, and not credit anyone that put the work in. And digital fabrication and making that distributable. So rather than having housing factories that take £500,000 to set up and then can churn out one type of house forever, we can have CNC cutting machines and 3D printers that can cost you less than £10,000 to set up a community workshop that can produce houses for as long as you need them, and after that it can produce repairs, extensions, furniture, whatever you want, and it can be an ongoing business and asset for an area. You can buy a CNC cutting machine to cut plywood. If you don't know what CNC is, no, computer numerical control. So this is the idea of being able to fabricate stuff rather than hand input, hand cutting, hand measuring. You design stuff on the computer and you send it to a machine that controls the output, cuts the shapes, and you can then just have a kit of parts. Automation and parametrics. So not only do we build stuff digitally, design it on the computer, cut it automatically, we can also generate a lot of that geometry and a lot of those components. This will all start to make a lot more sense in a minute. Automatically. So rather than saying I want a piece of wood here, a piece of wood here, a piece of wood here, okay, and with a piece of metal, you can have a system of rules that algorithmically just says, well, I want a wall this long, so that is 4 bits of wood and a piece of metal. And we can even start to apply that to policy and building regs. So decisions can be made about planning permissions and that kind of thing based on rules. And we can start to get data out of this process, rather than us all building houses, having no idea how they perform, and then more people building more houses that also have no idea how the other houses we've already built perform. We can make design decisions as communities and as professionals based on how other buildings are actually performing, about climate data from that actual area. And all of that, again, can be open source, can be Creative Commons licenses, so it's not just trapped as the intellectual property of big organizations that may or may not have any inclination to use it for our good. So, WikiHouse. So, I'm going to run you through the process of a WikiHouse, and quite a lot of this is showing you images from a house in Buckinghamshire near Rugby that's currently being built. Entirely self-build. So we build a detailed digital model, and you can see this is a whole series of components. They're all flat sheets of plywood. All the parts lay out onto 4x8 sheets of ply. It all locks together. And if we want to change a component, everything changes, so it's all sort of baked in. And what we're developing around that is not just making this accessible to designers, architects, professionals, but making tools which allow people to customize and design their own houses, and then it automatically generates the parts for you. This is parametrics in action. So this is some work that one of the guys in our team, Clayton, has been working on. You can see him dragging around the various controls, sliders, how thick do you want your walls, how many bits of roof angle do you want, what thickness are your materials. You want a pitched roof, you want a monopitch roof, and you can look closely, you can see it generating, when it comes back, generating all the pieces of wood with the joints in. So you're not having to redo that manual labor every time you build. So what this does is that actually, if you want a housing development with 100 houses in, all self-build, all a bit different, you don't have to pay an architect to design every single one individually. You get, skipped on, you can have customization with no extra cost. And then you press the Nest button, the big red button you saw on the last screen, and this happens. It sends it to a CNC machine which cuts the parts for you. And what you end up with is basically like an IKEA kit for a house. So this comes out of the machine pretty quickly. If you've got one machine, you can print all the parts for a house in a few weeks. And then it's very fast on site. You can also spot, if you look between the machine moving, you'll see the labels of all the parts. So it is literally like an IKEA kit. So part 6 goes into part 4. There we go. And so that's what a workshop looks like. That's a few £1,000s worth of kit. This is actually a Blackfoot CNC machine, which is made itself out of CNC cut plywood. So once you can buy one machine for your factory at the local community. Once you've got the first one, the first job is to build 2 more so that you can build the rest of the houses faster. So that's the factory of the future. The factory of the future is not a big proprietary owned factory sitting in the middle of nowhere in some industrial estate churning out houses that no one wants or no one's asked for. It can be led by communities. And at the moment we're working with CNC cutting technology because it's available and cheap. There's some very exciting explorations, if you've been following the news around Moon and Mars bases. They're looking at 3D printing technology. So they're taking planetary dust, binding it with resin that they'll take with them. At the moment that's not viable for co-housing. But it will be, probably in the next 10, 15, 20 years. Loughborough University, for example, is doing some work around 3D printing concrete, which is very exciting. So this is a picture of what the construction industry doesn't do. So we've talked about the technology, and then the wrapper we add to that is about collaboration and open source. This is a software hackathon. This is thousands of people getting together with free food and deciding they're going to solve some problems that the population or the industry wants solved. And this could be anything. And often these are around sort of high-impact things, developing stuff. The NHS has in fact started doing hackathons recently to develop new pieces of IT infrastructure that will help them deliver care to patients. Because these people don't know the rules. They will just develop the best solution. And if it's safe and if it works, the industry can take it up. And imagine if the building industry did this, instead of each little person, each little table, each practice, each office being its own little silo, which is what we have at the moment. Individual businesses keep their own data. And the thing is, they don't actually largely have much intellectual property to hold on to. And if an architect gets an offer from Detail magazine, which is a sort of well-known, widely published magazine, they are called Detail. They publish details. The architect will say, no, I'm not going to share my information. Oh, I'll get published in a magazine. Here's all the details from my building. So there's this sort of group conspiracy that we think, we'll just obfuscate all of our information. And it's massively inefficient, and it means that we end up drawing bits of wood over and over and over again. And that makes architects charge 10 to 15% to design you a house, which makes them unaffordable. So what we can build instead is like GitHub, if you're familiar with that, for software, like a Wikipedia, a collaborative commons for construction and construction solutions. So once someone has solved a problem, it doesn't have to be solved again. And you can take a kit of parts. I like that solution for my windows. That person's done a really good foundation detail. I can put those together into my building, and that information, my innovations, get re-uploaded. And what I pay for in professional services is innovation, not releasing intellectual property that someone else already paid for. So this is that house in Warwickshire going up. This is not a professional construction team. This is a bunch of self-builders. This is a time-lapse over about a week. It's a 3-bed, 2-story house. It's a sort of barn frame, basically. These are portal frames that you raise up and tilt up. The stubs you see at the top will eventually receive the second floor roof, which again you build on the ground and lift up. It all just slots together. You do end up having to use a few screws, but is the reality of, even if it only takes a week, you still have to protect it from the rain, because that was the time of year they built it and it started pissing it down halfway through. So most of these people on site have never built a house before. This is the second floor going on, but still very quick. And we probably had 60, 70 people over the course of this first week building the frame, and then a second week getting it to envelope, so putting the cladding on, putting all the house wrap on, putting the windows on. And they've now slowed down, they sort of don't have so many people visiting. But so it's an amazing teaching exercise for people coming through. We just sort of put this on the WikiHouse Foundation website, and people sort of just turned up. And it's also kind of interesting because one of the challenges around self-builders was mentioned earlier is, how do you deal with predictability? How do you deal with safety? How do you deal with all the realities of managing and running a site? Well, you can deal with a fabricator who will say, your parts will be finished in 3 weeks' time. They will come in 6 boxes. They will weigh exactly this number of kilos, because we know exactly how much wood is in them. And if you want, tell me what order you want to build the building in, and I'll stack the parts in that reverse order in the van, so they come out in the opposite order into your tent, and then you can put them up. The pieces you need first will be at the top. So there's some really interesting things that come out of developing and delivering buildings like this that make the process so much smoother. What you can't see just out of view at the top, but you can see the guy wearing the harness, is at first floor and then at the top of second floor level, we've got fall protection already built in. So the loops and holes through the building. So one of the things on a construction site, if you're working at height, you need to make sure you've got your high-vis and helmet, etc. But also you need to make sure you don't fall off of a roof. Because it all comes out of a machine, we can't forget that. It's just got a hole that you lock into already. So we sort of help with some of the safety and realities that often are just distressed or get overlooked. And what you get looks suspiciously like an IKEA manual. This is page 11 of 25. So this is frames X and Y, which are labeled. Then they've each got, this is X/S1, RS, etc. All the parts are numbered. You just go through your shed and find the bits that have arrived. Or ring the shop and say, it hasn't arrived, and I know which bit it is. Can you print me another one? I broke it. Which does happen. So that all goes together. I think, this not anecdotal, this external manual had 25 pages. That's all the pages you needed to build the entire structural frame of a house. And really understandable. Those are not people with building industry expertise trying to decipher plans and details. So this is how the system works. It's these box section frames that you tilt up, and these joints that lock together, purlins that run, then lock into those. These are all insulated before you put them up, and then you put insulation between. And also things like services, wiring holes, etc. Window placements are all in position, all perfectly accurate. If you think you need 35.5 meters of pipe, you will need 35.5 meters of pipe exactly, because that is exactly the distance between that and the drain, because you measured it and you printed it. You're not cutting a hole with a hacksaw. And one of the it's almost creepy, when you put the windows into a building like this, usually, as any architect or builder in the room, if you find them afterwards, will tell you, they're never square. So you end up leaving a sort of large gap around the windows, and you pack them and you wedge them and you try and get them to work, and you make them airtight. You have to sort of, double check and tweak. And then if the building settles or moves, the things jam. This is perfectly square. So you push the window in. We use an expanding foam tape to sort of grip them in. No packing whatsoever. You just sort of push it in, it makes a nice sound. And then there's a little frame that we put on the front edge which it stops against. So you just go, window installed. Next window. So that's the building with the roof on and the sheathing on. So this is both structural bracing, and it's also the barriers for fixing on the cladding, and the air barrier on the inside is fixed to it. And I really like this photograph, partly because it's a really great photograph of some of the people that helped. There's a couple of people hiding in there, Alistair, for example, who's of WikiHouse Foundation, who went on to help. And there's also the couple sitting down here, who are a teacher, and the guy of the couple runs a plant nursery on site. So these are not technical people. They lived in a caravan for the duration of the build, as is the tradition of self-build. But what's really great about this project is, and that photograph, is that it reminds me of this, which is an American Mennonite barn raising. And what's wonderful is people often say when they see the system and stuff we're working on, oh, this is very radical, it's very new, how can you get planning permission, how can it possibly meet code? The answer is, well, it's not really that radical. It's a timber frame, which we already know how to build. All we've done, really, is we've done some fancy things with digital construction and how we print it and build it, cut it. But we've taken out the little packers and little blocks of wood in the corners and screws and replaced them with slot and peg connections, which isn't innovative. It's just moving things back to another way, and it's doing something now which we can now do because of new manufacturing technologies that would have just been expensive to do by hand. So that building, some stats now, because I haven't had enough words yet in the presentation. That cost just slightly under £100,000 to build. It's about 115 square metres, 3-bed house. It took 2 weeks to get to enclosure. So 1 week to build the frame, another week to sort of wrap it. And within 5 millimetres of the digital model, built by amateurs. So that works out at about £800 a square metre, just for one house. So we don't have the luxury with this particular house of the sort of scale of sort of co-housing development. We're really excited to see what that happens. We have some conversations at the moment with housing associations to see how that affects the cost and the procurement model as well. Anyway, it was something which is modular, predictable, but very fast to build. If you want to extend the house later, you know exactly what's in the walls. You just print a bit more and add it on. If something breaks, it's all digital, it's all in the library. In some ways what we're doing is taking if people have heard of BIM, which is a sort of new paradigm in drawing and producing buildings for professionals, where you have a complete 3D model, a digital model of a building, but it's very expensive, very difficult, and a lot of professionals are still struggling to get their heads around it. We're taking that kind of model of keeping things digital, but making it accessible to everyone, end user and professional alike. And we can't say that these are passive houses, because that is determined by what windows you choose to put in, whether you seal it properly, etc. But we like to talk about it as sort of passive house ready. That you have a 300mm thick wall which you can insulate. You've got a barrier for air tightness. It's accurate. You don't have any gaps or any surprises. You don't have any bodge details that if the architect doesn't catch them, the builder might not realise he has to deal with, and you've got an air leak. So as long as you do what you need to do on top of this system right, you're going to have a really high-performance building. And not at any extra cost. It just comes out of the box like that. And this is the last example, well, a few examples now of other projects we've been doing. We did this last year outside the building centre. This was a bit of a race against time. 8 days, 8 amateurs, again, 5 mil of the digital model. This has now been dismantled, taken up to Liverpool. If any of you have heard of Friends of the Flyover up there, doing some great restoration work, this is being reconstructed as a teaching space for their community project. So that was quite an interesting example of we got to build it, we got to dismantle it even faster than we built it, put it in the back of a van, and luckily we knew how big the van needed to be because we can calculate it, and sent it to Liverpool, and they're rebuilding it. So we get to see the reuse of parts as well. And again, really demonstrating the end of life. It literally just comes apart. So, and then a couple of examples of sort of typologies that we've got. A couple of these have actually been built now by groups around the world. We have this, being an open source project with the community, we have this weird model where every so often people will, quite regularly actually, people will ring us up and say, we've built a WikiHouse, here are some photographs. They won't have told us. They'll have just gone on and done it, which is really, really exciting. So studio, sort of small space, less than a week to build. And that last one, this is available on the website. So you can go to the WikiHouse CC website, and you can download all the information for this. If you want, you can get someone to build it for you or help you, but you can just download the cutting files, the sort of shopping list of all the other parts, everything. And that's sort of our model, which I'll just talk a little bit about later. Microhouse, so again, a sort of single-story sort of barn-type volume, and something we're working on at the moment, which is actually, at the moment the system is engineered with help from Arup to 2 stories. And we're adding a 3rd story into that, so once this typology is developed and put into the parametric model, this is suddenly very flexible. You can go up to the width of a sort of standard UK terrace, up to 3 stories, and you can basically extrude it back as long as you want. So you can generate the structural frame instantly, online, for the vast majority of the UK's housing stock. And we're estimating the price is probably going to be about £150,000 for one, assuming you're self-building. So there's been about 300 projects, this is sort of where we're at, of various levels, around the world. This is a kind of cool project. It's a bus shelter in Scotland. It was built some years ago, a sort of early prototype. And these guys up here, one of these people that just sort of got on with it, this is WikiHouse New Zealand. And a great example of one of the innovations they've added is they have earthquakes. They're helping to rebuild Christchurch using custom and self-build after the severe earthquakes a few years ago. And so they've just engineered and altered the frame to make it earthquake-proof, which is amazing. One of the innovations they came up with were box frames, which have now been rolled out into the WikiHouse UK structure, because it was more efficient. So this is an example of us learning from open sourcing and sort of communalizing learning. So we have the WikiHouse Foundation, which is a non-profit. To put this in context, we have 28 chapters that are kind of local advocacy groups that do what I'm doing now, this kind of thing. I'm a member of both WikiHouse UK and WikiHouse Foundation. And we have about 2,000 members in the community doing one level or other, either from individual people saying, I'd like to build a house, I'm playing with a system, to 300 startup teams like WikiHouse, New Zealand's team, which is called Spacecraft, or 00, architecture firm in the UK, who are actually deploying and designing WikiHouses at the moment. So you've seen a lot of the chassis, but the vision goes beyond that, to have ways of acquiring and dealing with and parametricizing land and regulations and rules, to our heating and cooling systems, water, appliances, building data and monitoring, smart building controls, furniture, etc. This kind of ecosystem, a sort of full stack approach, rather than saying we just deal with one piece of technology, we can have a whole kit for a building, start to finish. And some of the things that have been developed so far, these are 3D printed or CNC cut windows, not the glass yet, we haven't quite got that far, a few years off. These are weather resistant MDF, early prototype. Smart building systems, so this is kind of cool. So this is using Arduino. Does anyone know Arduino? If you might know Raspberry Pi, it's similar. It's a sort of small open source or open sourceable computer, which you can program to do what you want. And it's a sort of cigar box kind of size. So this is working alongside Arups again, using low voltage distribution. So we have central, I'm running out of time apparently, central distribution, 230 volt, and then Ethernet and USB. So it's all smart, distributed to where you want in the building. So you can do the electrics yourself, which again cuts cost and makes it more viable. If you want to rewire your house, just do it. It's not high voltage, so it's safe. And it's all smart, so any appliance you plug in, is an intelligent piece of kit. You can turn it on and off using a smartphone, which worked wonderfully until everyone realized that they could log into the internet and turn the building off with voice control. This is an open MVHR, cheaper than an off-the-shelf type vent Axia. And again, wonderful piece of hack technology, Budweiser cans, which gives you an insight into Arup's internal workings and working methodologies, and that's 3D printing rather than CNC cutting. So it's the idea of this sort of tree of you can develop new technologies and we can sort of put them all together. Until someone develops a new technology, we've got a team in Malawi, for example, at the moment looking to develop earth and brick technology, but using the same principles. And if it applies, if it works and it combines with our principles of it being open source, it being self-buildable, then it's WikiHouse. The CNC chassis is just the first approach. I'm going to skip through these because these are a bit techy and talk about BIM and integrated software platforms, which is what we're currently building. The last bit, which is really important, is that architects, engineers, etc. often say, this is a bit scary, this is going to put us out of business. People can design their own houses. No, most people are still going to want, or a lot of people are still going to want some kind of design or professional input, even if it's just how on earth do I get through the planning system. So we have this idea that as well as having bottom-up production of new technologies and hardware and products, we can then certify those products. So these are actually WikiHouse certified. We can pick them out and curate a kind of catalogue of compliant products. And we can do the same thing with providers. You can be someone and just be doing the WikiHouse system, but if you want, a bit like you can be Passive House certified, you can also be WikiHouse certified. And that's everyone from designers to builders, manufacturers, etc. But also a tranche of other people that know the system and will work with it, funders, insurers, maintenance teams for bigger projects. Just skip through these. This is just showing our sort of workflow and the stuff you can download offline. And you guys already know this. This is, Paramount Pictures versus YouTube. It might sound crazy, but the long tail is very powerful. And for transparency, this is our funding model at the moment. We intend to build, or we are building at the moment, an online marketplace, which we've got grant funding for and are currently match funding for. And these are a series or a set of our current partners, both building industry professional bodies like 00, Building Centre, Arup, but also some interesting people like Australia's biggest insurer, Suncorp. Because this kind of stuff, adding this amount of certainty and changing the building industry model this much, if it becomes mainstream and widely used, is going to really affect people like insurers. How do you insure a building? How does the insurance model change if you know exactly what's in the building, if you know exactly all the building data? And if it's not built by big companies that have big liability and legal costs, if it's just built by self-builders. So thank you very much. Thanks for the comment.